Welcome again to the fabrication and assembly of what I'm calling my Big Blue router. I believe this will be video number 8, and if you recall, last time we had the X-axis gantry assembly moving. It's a nice move. Nice even pressure front to back. Today we are going to continue with the Z-axis build, and you'll notice right off the get-go that I have my mounting plate affixed to my bearing blocks. And before I go any farther, this is just here to illustrate vertical alignment here. But one way that I had to deal with alignment of my linear rails end to end. And again, remember, this build is all happening without the aid of any, I guess you want to call it, elaborate measuring or machinist tooling. So far, it's all been done with a hand drill, hand tapping, of course, a powered miter to do some aluminum cutting, and a pair of verniers, 6-inch verniers. Now these are old school dial verniers. Of course, in today's world, pretty much everything is digital, and I do have a pair of digital ones. But these are my verniers that I keep here in the shop. And they do the job quite well. And this is what I use. Remember, this is what I use for my layout. Take your calculations, scribe your material, scribe very accurately, center punch very accurately, and your holes will be very, very consistent with what you're looking for. So now, what I would like to illustrate is that I have mounting my quarters all mounted up here. My uprights, they are square. My guide rails are square to the bed, and my Z-axis mounting is also square to the bed and in the X plane. And I can illustrate that real easily with, it's not a machinist square, but it's a typical framing square. And what I do is I just take my clamp, good old woodworking clamp, I make a base for it. I'll just hold it upright. Real simple. It doesn't have to be elaborate, and it serves the purpose quite well. What I'm going to do is I'll just move this over to my mounting plate, and I don't know if you can see it that well at this distance, but what I'll do is I'll shine a light top to bottom, and there's no light coming through there. Now, granted, this is coming off of a wooden surface. This is particle board. Is it accurate to within a thousandths or two? Oh, heavens no. But the machine itself will be accurate from end to end, front to back. Probably, I'm going to make a wild guess and say a statement of perhaps plus or minus 5 thousandths. And it's all done with hand tools. So I'm straight here. I'm straight here in the vertical plane, and again, I would have to reposition all of my recording equipment, which is an old standalone camera that I used to do all this recording. That's why I mentioned earlier, this camera does not have a forward-facing screen on it, nor does it have a rear-facing screen. It's strictly through the lens. Old school, kind of like me. And At any rate, I'm square here, I'm square here, I'm square across the ends. Now, so I hear somebody saying off in the background, how did I get my alignment across my guide rails to begin with? And that is very easy. I simply used my woodworker's machinist woodworker's combination square, excuse me. So, and use it like a depth gauge. So I have a measurement here that I'll take. It gives me a depth there. Be careful you don't move it when you pick it up. And of course, this old scale you won't be able to read it, but it's 9 inches and 1/32. Come over here and do the same thing on this end. Hold it up snug, not so snug that you can't move it. Read the scale, 9 inches and 1/32. Now that's a visual measurement. And what I would like to just illustrate briefly, just how close you can get with that simple measurement. And I will come over here and get my, now this is the only precision tool that you'll see me use or introduce, and I'm not using it, I'm just using it for illustration purposes. But it's a dial indicator, and I can come over here and I'm reading minus 5 thousandths there. Let's zero it out. Zero. Now again, you're going to have to kind of trust me a little bit on this one here. I'm not going to move the camera and show you. I could. And come all the way to this end over here, plus 5 thousandths. Across 52 inches, I have 5 thousandths run. Do the math. That is all. The run out per inch is nothing. And again, this is measuring off of a wood base. So you can get things very accurate with a little bit of time and care and simple everyday tools. So let's set this off to the side, turn it around so I don't bump it and break it. But what you'll do is you'll run your bearings, and you need your bearings affixed to your mounting, the Z-axis mounting plate to do this. What you want to do is, first of all, remember these rails were loose. Affix your mounting plate to align the bearings. Come along, snug up the top and the bottom, one end. A couple, 3 places, a single place, you don't have to do everything. Come over to the opposite end, do the same thing, and work back and forth, continually aligning this bearing rail to this one. And that's what these bearings will do for you. Pretty much self-aligning. So just work end to end, make sure you have everything all snugged up. So it's as simple as can be. Just a little bit of effort, slow down, don't go fast, and you'll get the machine very, very, very close with just simple hand tools. Now, what I'm going to, I'll go ahead and take this this mounting plate off. I just have it temporarily affixed up here with these 4, and we'll go ahead and set line up for our guide rails for the actual Z-axis, and that'll be our next operation. So I'll take a short break, take this off, and show you how. Oh, before I go too much farther, and again, somebody's asking, how did I get my placement for this? Well, your manufacturer should be able to provide you with, where you purchased your bearings from, a small schematic showing you hole placement. If you can't find one, It's very, very easy. Throw half things on the floor. We don't do that. On your bearing, take a screw and just screw these are extra long, screw them in until they just bottom out. You don't have to snug them down until they just bottom out. Take your calipers, measure cross distance, get a good reading there. Once you have that reading, subtract the diameter of one bolt, and that'll give you center to center distance that way. You're going to do the same thing in this direction. Take a measurement, subtract the diameter of one of your bolts, in this case it's 5 millimeters, and that will give you placement of those screw holes center to center. And that's how I determined all of this information here for my mounting plate. Again, just take your time, everything will come together, and you'll be surprised on how accurate you can get this. So give me a second, I'll go ahead and take this apart, and we'll get it down to the table, and I'll show you how I'm going to approach layout of the Z-axis mounting plate. Okay, I have the components roughly laid out in position on my Z-axis mounting plate, and what I'm going to do now is I need to determine where I'm at center-wise. The best way, or the way that I did it, I don't know if it's the best way or not, but the way that I did it was simply to take the components, and knowing that I'm going to have some distance between the bearing block and the bearing supports, I'm going to use a couple of steel rules that I know the dimensions on. In this case they're 70 thousandths, and I can measure from here to here. That gives me the width, and I know the width of my plate here. Okay, that difference divided in half gives me a number from edge of mounting plate to edge of the linear guide rail. And in this case, in my case, it's 293 thousandths of an inch. And I'll lock this down. And then I just use my vernier as a gauge and move this over to it. Top half over to it. Repeat on the other side to make sure that I'm in the center, which I am. And you can actually use if you don't push really, really hard, and you have a good lock on your vernier, you can use it as an actual depth gauge to measure to. But there I have 293 thousandths here and here. I know I'm in the center, so easy enough. Now, what are we going to do here? Well, I know, and this is strictly a visual, this plate is going to get a little busy. So as I look down, I can see that mounting holes for the for the floating end bearing are sitting on top of the holes for the bearing mount to the Z-axis. So what I'm going to do is I'm just going to reposition it, and this is strictly a visual. Again, nothing super complicated here. And I'm just going by feel across the edge of the block up here, and it gives me a pretty good idea of where I can drill these holes. And of course up here I don't have any interfering holes up here, so I can do those right in position. So, and again, distance here, equal distance. So everything is aligned central. The next operation, and you've seen me do this before, is strictly to take my drill down through the mounting holes for the linear rails and just mark the plate. No layout required, simply mark it. But before you do that, you want to make sure that you affix either the center point or somewhere along here. Take a couple of good C-clamps, not your woodworking clamps, but use C-clamps. Get a good bite on this thing. Squeeze it together, hold it in position so it doesn't move on you, and go ahead and spot your holes. Now, in my case, I can't get to all the holes at one time. So what I'll have to do is I'll have to spot, drill and tap, affix the rail to the in position, and then move my bearings up out of the way and complete the operation. So it'll be a couple of steps for me. Not a big deal. It just takes a few extra minutes to drill and tap those holes again once you have the thing assembled. So I'll spot the holes on this side, affix this rail down, make sure my alignment is good. Go ahead and spot these holes on this side, and you can also spot your bearing mount holes and do that at the same time also if you're so inclined. So you've seen me drill and spot these before. I don't think it's really necessary that I repeat that operation for you. Well, the rest of the holes are drilled and tapped into the Z-axis mounting. Let's put it together and see what it looks like. Grab one of our guide rails. It looks pretty good so far. Only kidding. Alright, let me throw it. 5 inches, 408, 2000s. So on 2000s out of parallel, you know, I would say that's pretty darn close considering my precision alignment tools that I'm using. So 2000s, I can live with that. 2000s and 14 inches. Of course, we lucked out on the x-axis, and we were able to spread the difference from one end to the other out over 52 inches was made at a very, very small number. 2,000 is over 14 inches. I haven't done the math on that, but it's the run out per inch is not much. The next challenge that I have is finding out my spacer distance that I'll need from surface of bearing block to the back side of the bearing nut. So there's probably an easy way to do this, easier than I'm going to do. I just don't know what it is yet. And if I were to probably give it some thought, I'd be able to come up with something. But as luck would have it, I have these nice parallel ground spacers. Guess where they came from? Cutoffs from the linear rails. Alright, so I know that those are a given distance, and I don't remember exactly what they were. 684 thousandths. 684. Double check that. For some reason that doesn't sound right. Yeah. 683 and a half. I'm going to call it 84. And I have some flat washers here that are 54 thousandths. Both of them are the same. And this should give me, I hope, a number that I can begin working with to stay up off of my T-nut. Chances of me getting something that's going to lay on there, it's going to give me a number exact, are probably slim to none. So I guess one shim was not enough. Okay, I don't know if you can see this, but it does rock just a little bit. That says that I am up off of that surface. So this thickness plus those two washers gives me a number that I can work with to try to figure out how much I have to pick this this rail assembly up, rail and guide bearings up, in order to give me a clearance across here. Of course, that number can be anything. And right now, I will use this number to calculate what I need. And it's looks like with that stack up, and again, this is just a crude measurement, and I'm going to go eyeball right to the center of the ball screw so that I keep the block from tilting, I hope. I've got a rock falling apart here. I should probably have super glued these washers together. And I'm right at 105 thousandths. Roughly 90 that time, 205. I'm going to say if I do an average, I'm pretty close to 100 thou from the edge of bearing block to this top side here. and what I'll have to do then is subtract the difference from here to here, and that'll give me my distance across there. And this total assembly will have to be adjusted to either try to bring this all down flush, which would be ideal. I don't know if I'll be able to do that without doing some machining along the way, which I can't do, or trying to work with some precision ground shim stock. And I can get precision ground flat washers, and I'll try to work with those first, and we'll just see where it goes. But this is the assembly of the Z-axis mounting plate. Remember, and I can't go much farther than that, I'm still waiting for my my spindle mount. Remember, I mentioned that the spindle mount plate and my mounting axis mounting plate were cut from the same stock, which is only 6 inches wide. And I guess an error on my part, I didn't take into account the overhang of the bearings. So it says that I need roughly, that doesn't go right, 6.5 inches edge to edge, 6 1/4. I'll make it, I'll go with a nominal size of 6.5 wide, and probably looks like 6 inches, maybe 6.5. Maybe I'll go 6.5 square. Once I get that mounting plate, I can affix to here, transfer the holes again, just as we've done with everything else, and more drill and tapping. So, speaking of drilling and tapping, be very, very careful with your drill bits. They will get you. And this is not the first time, and I'd like to say it'd be the last, but I seriously doubt that. So I think that pretty much wraps up video number 8. I will rejoin with the mounting of the plate to the x-axis and the drilling and tapping of the spindle mount, and it's starting to get pretty close, starting to look like something now. So I'm getting anxious. And once we get the Z-axis mounted up, we'll go ahead and mount the ball screws for the Y-axis, get that all mounted up, and then figure out how we're going to mount up the motors. I'm still not real sure how I'm going to handle that, but it'll come into play.